Well, alright, today we're going to be working on the traveling salesman problem. This is where we're going to find the fastest, cheapest, and shortest route between places or locations. So alright, let's go. Right now, I'm going to drive over to Mission Hills and we're going to figure this out. You write down the objective. Let's go.
Somebody that knows something about it. And I won't answer now. Who, what, where, why? See, a lot of dudes like to act the fool now. Get on live, but that ain't my style. So who he gon' get and what he gon' do? Run up on me if you want to. Hot damn pressing his homies. He's done up in front of his mama. I'm up the floor with him.
Okay, let's stop for a minute and talk about three things: travelers, sites, and costs. Travelers are just the person who's driving around. That's you, that's me, that's the FedEx guy. Next, let's talk about sites. Sites are just locations. They're places. They're Best Buy because you have to pick something up from there. They're someone's house if you work for FedEx. They're a moon if you're an astronaut. Whatever. They're just places. Costs are just what's in between each of the locations, each of the sites. They're the money that it costs to go from one place to another, the time between, the distance between. Those are the key ideas of what costs mean. It's what each one would cost to go from one place to another. A tour is simply a trip that starts and ends at a designated site and visits each site only once. So basically it's just a traveler that goes to all the different locations and ends up exactly where they started. That's a tour. An optimal tour is just a tour, but it's the fastest one, the cheapest one, or the shortest one. It's basically, well, look back at your objective. That's what we're trying to do. We're trying to find an optimal tour. That's what mathematicians do. They don't just try and find one place to another, but what's the cheapest way, fastest way? How can we get this done in the most efficient way possible? That's what we're trying to do here today. Seriously, did I hit every light on the way over here? Feels like it. Anyway, we're talking about the traveling salesman problem. And all it is a situation where you have a traveler going to a bunch of different sites, accruing some sort of cost along the way, and then coming back to where they started from, usually their house. So that's just a tour. So, what's our goal? We're trying to find an optimal tour. The cheapest, fastest way to make it back to where we started from. So we're going to be talking about school buses, delivering packages like for UPS, and then fabricating circuit boards. So we're going to get into all that and do some examples and figure it out. Alright. Alright, made it here. Now that we've talked about sites, costs, tours, optimal tours, now we can actually get into solving some problems. So I'm gonna go home and he's gonna take it over now.
Trying to catch me riding dirty, 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 trying to catch me riding dirty. My music's so loud.
Alright, well that completes your tour. I'm back to where I started from, And now you've got a couple problems to do. And I gotta go home before this gets a little too creepy. I don't even live on this street. Alright.
They hoping that they gon' catch me riding dirty. Tryna 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 catch me riding dirty. They can see me lean. Tense, so it ain't easy to be seen. When they see me ride by, they can see the gleam. And I shine on the deck in the TV screen. Ride with a new chick, she like